Welcome back, everyone. In this video, I will be showing you how to integrate this function. So first, we're going to go ahead and distribute this, and then we'll try to use identity and probably use substitution as well. So let's get to it. So we have the integral of, if I distribute sine cube x to sine x, I get sine fourth x plus, and then sine cubed times 1, that's just sine cubed x dx. All right, so once we have done that, I'm going to separate this into two separate integrals. So this is the integral of sine fourth x dx plus the integral of sine cubed x dx. All right, so now for the even power one, we're going to use the identity. So this is the identity we're going to be using. We have sine squared of x is equal to 1/2 1 minus cosine of 2x. So that's going to be the identity I'm going to be using for the even power. So I'll split it up into power of 2. So we can rewrite the first integral as sine squared x times sine squared x, because that is sine to the fourth power x. The second one, I'm going to do a little bit of rewriting. So I'm going to pull out one of the sine x. So you have sine x, and then you rewrite sine squared x. Now this one, I'm going to rewrite it a little bit differently using the Pythagorean's identity. We also know this identity. We have sine squared x plus cosine squared x equals to 1. So that's another identity we know. Now here, I'm going to solve for sine squared x. That means sine squared x is equal to 1 minus cosine squared x. So that's what I'm going to replace here. But for the first two, I'm going to rewrite, and I'm going to replace it with this one, because that's the one that's going to help us. So for both of these. So these are the two variations of the identities we're going to be plugging in. Let's go ahead and do that. So for the first two, we have the integral. So sine squared x, that's 1/2 1 minus cosine 2x, and then another 1/2 1 minus cosine 2x dx, plus now the second integral, we're rewriting. I'm keeping the sine x, and I'm rewriting sine squared x using the second identity above. That will be 1 minus cosine squared x dx. Now, these we're going to expand and rewrite, but this one you can integrate by using U substitution. So this can be done by U sub. I hope you can see that. But the first one we have to rewrite. So I'm going to go ahead and expand. So let's focus on the first integral. We pull out the 1/2 from both of these. So that's 1/4. We have the integral of, if you FOIL or expand, you'll get 1 minus 2 cosine 2x plus cosine squared of 2x dx. And then for the second piece, well, we're going to be using the U substitution. So let's do the second integral. Let U be equal to cosine of x. So the reason I'm choosing U to be just this part, because its derivative is right there. So that means if U is cosine of x, we know du is negative sine x dx. And that's fine because we can just pull out that -1. So let's go ahead and rewrite that integral. So this will be the integral of, so because of that negative, I can put it right here, negative, the integral of sine x dx. So these two are replacing with negative du. So we have negative, and then 1 minus cosine, that's going to be 1 minus u squared du. So that's how the U substitution works for that integral. And of course, we can integrate that using power rule of integration. So this is simply, so negative integral of 1 respect to u, that's just u. An integral of u squared, that's going to be, so distributing the negative, so positive u to the 3 over 3. And of course, plus c. And then I plug in u into my u's right here. So that this piece of the integral gives me just negative cosine of x plus cosine cubed x over 3 plus c. So I finished that one. Now we just need to take care of this piece right here. So let's do that. Now, before I integrate this one and this one, I need to apply the double angle formula for that one. So if you go up, the double angle is for sine square of x. That means if you're looking for the double angle for cosine, that's going to be cosine squared of x is equal to 1/2 1 plus cosine 2x. So that's for cosine square of x. Now, if you have cosine, let's say cosine square of 2x, then you have to double the angle. This would be 1/2 1 plus cosine of, instead of 2x, you will have 4x. So that's where I'm going to replace on the bottom, and then we can integrate. So that is the identity we're going to replace right here, because this is what we have. Okay, so if I replace that, I'm still rewriting the integration. So this is 1/4 the integral of 1 minus 2 cosine of 2x plus, now cosine squared 2x is going to be replaced with that identity on top. That's 1/2 1 plus cosine of 4x dx. All right, so that's that. And then now we can integrate this piece by piece. So this is 1/4 times, so integral of 1 respect to x, that's just x. Then integral of this piece, well, that's going to be negative 2 sine of 2x divided by 2. Think of it as a u substitution, plus, and then we have a 1/2. Now I'm integrating this 1. That's going to be, again, x. And I'm distributing the half as I'm integrating. That'll be plus integral of cosine. It's going to be sine of 4x divided by 4, and then times the 1/2, so times 2. And of course, we're tagging along the answer from the previous integral. Now carrying on with this. So we have finishing up 1/4 x minus, here these can cancel out. So you just have 1/4 sine of 2x plus, and then here I'm going to go ahead and distribute the 1/4 to the next, the third term. That's 1/8x plus, and then here I get 1/32 sine of 4x, and tagging along these answers and the integration constant. So this is minus cosine of x plus cosine cubed x over 3 plus the integration constant plus c. All right, so this is a nice answer, but now we can just go ahead and combine some of the common terms, like this one and this one. So that would give us, putting them in common denominator. So I times the first one by 2/2. So that's 3/8x. Yeah, I think that's pretty much it. There's no other common term. I'm just going to rewrite the rest. 1/4 sine 2x plus 1/32 sine 4x minus cosine of x plus cosine cubed x over 3 plus c. So that will be our final answer for this problem.